Good evening, guys. Let's start with problems based on Laplace transform today. And in previous class, we had gone through the definition of Laplace transform and some basic properties of Laplace transform. And also we have solved some Laplace transform for standard functions. And today we'll start up with the problem. Laplace transform of 4t square minus 5t plus 7 is equal to, I've just used the property of linearity here. Laplace transform of 4t square minus Laplace transform of 5t plus Laplace transform of 7. I have just split all those terms, and here we know that Laplace transform of t power n. We have done this in standard functions. Laplace transform of t power n is equal to n factorial by s power n plus 1. So here Laplace transform of t square, 4 is constant, we'll take that outside, and Laplace transform of t square, see here in place of n I am having 2. So it is 2 factorial by s power 2 plus 1, that is 3. So 2 factorial by s power 3. Similarly, I have taken 5 outside, okay, and it is Laplace transform of t. And here that is nothing but t power 1. T means t power 1. So in place of n, I am having 1 here. So it is 1 factorial by s power 1 plus 1 according to this formula. So it is 1 factorial is 1 and s power 2 plus Laplace transform of a constant a is a by s. So it is 7 by s. Okay. So if you take this 7 outside, you will be having Laplace transform of 1 and that will be 1 by s. So it's all 1 and same. So at last I have just solved this. 2 4s are 8 by s cube, 5 1s are 5 by s square, and 7 by s. This is the final answer for Laplace transform of 4t square minus 5t plus 7. Okay. Second problem. Laplace transform of 4 into e power 3t plus 6 into t cube. For this problem to solve, I need Laplace transform of e power 8 and Laplace transform of a polynomial. So I know that Laplace transform of e power 80 is equal to 1 by s minus a. Okay, we have done this in previous class. Laplace transform of t power n is equal to n factorial by s power n plus 1. So you should be knowing all these formulas when you go to the problems. No, you should be knowing all these formulas, guys. So next, I've used the property of linearity and I've split these terms. So now when I take this 4 outside, I'm left with Laplace transform of e power 3t. So when I use this formula, that becomes 1 by s minus 3. Here it is 1 by s minus a. And here in place of a, I'm having 3. So it is 1 by s minus 3. And I have taken 6 outside. The Laplace transform of t cube is 3 factorial by s power 3 plus 1. So it is s power 4. So this is the final Laplace transform of 4 e power 3t plus 6t cube. Next problem. Laplace transform of root t plus 1 by root t whole cube. So I have just used the formula of a plus b whole cube. What is a plus b whole cube? It is a cube plus b cube plus 3ab into a plus b. See here, a is t power half, b is t power minus half. When I take cube, it is t power half the whole cube, that is t power 3 by 2, and t power minus half the whole cube is t power minus 3 by 2, plus 3ab means root t into 1 by root t is 1. So 3 into 1 into a plus b. A plus b is root t plus 1 by root t. So I have just used that formula of a plus b whole cube here. And I have used the property of linearity while splitting these terms. And now see here, when we get this fraction type of thing, no, we'll be using this gamma function. What is that? Laplace transform of t power n is equal to gamma n plus 1 divided by s power n plus 1. Yeah, and I forgot to tell you about this gamma function in previous class. This you have not learnt in first year. You'll be learning this in the calculus part, like in gamma function and beta function. You'll be learning this. Okay. Anyhow, you should be knowing this formula for time being. Laplace transform of t power n is equal to gamma n plus 1 divided by s power n plus 1. And also we have solved this in standard functions. Laplace transform of t power n we had done in two methods. Okay, first one is by parts and second one is by substitution method. So in that one formula is n factorial by s power n plus 1 and the other one is gamma n plus 1 by s power n plus 1. So I'm using that formula, and if it is a whole number, no, you can use that the other formula n factorial by s power n plus 1. And if it is like this 3 by 2, 1 by 2, 5 by 2, you can use this gamma formula. See here, and I have used this in this step. So gamma t Laplace transform of t power 3 by 2 is, see, in place of n I am having 3 by 2. So it is gamma 3 by 2 plus 1. So it is 5 by 2. And here also 3 by 2 plus 1 is 5 by 2. So it is s power 5 by 2. Gamma 5 by 2 divided by s power 5 by 2. Here in place of n I am having minus 3 by 2. So it is minus 3 by 2 plus 1. Minus 3 by 2 plus 1 is minus half. So it is gamma minus half divided by s power minus half. Plus, I have taken 3 outside, t power half. Gamma half plus 1 plus 3 by 2 divided by s power 3 by 2 plus this 3 I have taken outside. Laplace transform of t power minus half is minus half plus 1. Minus half plus 1 is half, gamma half divided by s power half. So see here, you should be you should be knowing these things. Gamma half is root pi and gamma n plus 1 is equal to n gamma n. So you'll be deriving how you get this gamma half equal to root pi in your calculus part. Okay, and here also this formula gamma n plus 1 is equal to n into gamma n. You'll learn these problem this formulas gamma n plus 1 is equal to n gamma n. You'll be learning this in calculus part. So for time being, you should be knowing these two formulas. Okay, and so it is gamma 3 by 2. I want see here, I want gamma 5 by 2. I want gamma 3 by 2, and gamma half we have a direct formula for that. Gamma half is equal to root pi, and derivation of that we'll be doing in calculus part. And I also want gamma of minus half. Okay, so we know this, so we'll go to find what is gamma 3 by 2 here. See here, I have used this formula. Okay, gamma n plus 1 is equal to n gamma n. I have used this here. See, I can write this 3 by 2 as half plus 1. Okay, gamma half plus 1 is equal to half gamma half. So gamma n plus 1 is equal to n gamma n. So in place of n I am having half here. So I have written half gamma half. Using this one I have written half gamma half. Gamma 3 by 2 is equal to half gamma half. I know it is root pi. So it is half root pi. And when you move to gamma 5 by 2, I can write this 5 by 2 as 3 by 2 plus 1. And again, using this formula, I can write this as 3 by 2 gamma 3 by 2. Okay, in place of n, I am having 3 by 2. So I will write this as 3 by 2 gamma 3 by 2. And gamma 3 by 2, I have done it here. It is half root pi. So total answer, that is, it turns out to be 3 by 4 root pi for gamma 5 by 2. Okay, and here for negative half, I have done in different way. See here, yeah. See, I can write this gamma n as gamma n plus 1 by n. Okay, so I have written this gamma minus half as gamma minus half plus 1 by n. Here n is minus half. See how gamma n is gamma n plus 1 by n. So gamma n is gamma n plus 1 by n. Okay, this is how I have written. And we know that minus half plus 1 is plus half. So gamma half is root pi divided by root pi divided by minus half is minus 2 root pi. And I have used all these values of gamma 3 by 2, gamma 5 by 2 and gamma minus half and gamma half here in this equation. At last, the Laplace transform of root t plus 1 by root t whole cube will be so much. Fourth problem, Laplace transform of 4 sine hyperbolic phi t minus 5 cos 4t. Okay, we know that sine hyperbolic at is equal to a by s square minus a square. And Laplace transform of cos at is s square by s square plus a square. So when when you use this here, okay, see I have just used the linearity property again, and now when I use this formula here, no, Laplace transform of sine hyperbolic phi t will be equal to, see here, sine hyperbolic at is a by s square minus a square. In place of a, I am having phi here, so it is phi by s square minus phi square. Since I had 4 here, 5 into 4 was 20, so 20 by s square minus phi square, that is 25. And here also cos 40, cos 80 is Laplace transform of cos 80 is s by s square plus a square, and in place of a I am having 4. Okay, so it is s by s square plus 4 square. And since I am having 5 here, I have written 5s by s square plus 4 square or 60. So this is the final Laplace transform of the 4 sine hyperbolic phi t minus 5 cos 4t. Let's move on to next problem. That is 3 cos hyperbolic 4t plus 4 sine 3t. So again you are using these standard functions. Okay, we should be knowing these formulas. Laplace transform of cos hyperbolic at is s by s square minus a square, and Laplace transform sine it is a by s square plus a square. I have just used these formulas here. Okay, cos hyperbolic 4t. In place of a, I am having 4. So Laplace transform of cos hyperbolic 4t is s by s square minus 4 square, that is 16. So I'm having 3 here, so I have written 3s by s square minus 16. Also, Laplace transform of sine 3t, this one. Here in place of a, I'm having 3 here, so it is 3 by s square plus 3 square. I'm already having 4 here, so it is 4 3s are 12. 12 by s square plus 3 square or 9. Okay, so this is the final answer. Laplace transform of e power bt plus 1 whole divided by b. See, I know what is e power 80, this one, Laplace transform of e power 80. I'm having bt here, that's it. If this is 1 by s minus a, for this I'll be getting 1 by s minus b, that's it. And I know the constant, Laplace transform of constant is a by s. Laplace transform of a is a by s. So 1 will be 1 by s. See, I have taken this b outside the Laplace transform. So this is the constant. And I have used the property of linearity. And I have split these terms. L of e power bt plus L of 1. So in both the terms, 1 by b is common. I have taken that outside. And L of e power bt is 1 by s minus b plus Laplace transform of 1 is 1 by s. So I have taken LCM in the next step. So it is s plus s minus b, that is 2s minus b by s into s minus b. So this is the final answer. Yeah. Here they have given cos hyperbolic square 80. Okay. Laplace transform of cos hyperbolic square 80. We know that, see, we know this formula, that is cos hyperbolic 2x is equal to 2 cos hyperbolic square x minus 1. So I have used this identity. See here, I can write this cos hyperbolic square x as, see, I can take this minus 1 this side, so that becomes cos hyperbolic 2x plus 1 whole divided by 2. Okay, and here in place of x, no, in place of this x, I'm having 80 here. Okay, I'll just replace by that. I've taken half outside, Laplace transform of cos hyperbolic 280 plus 1. Okay, and whole divided by 2, I have taken that outside of the Laplace transform. So now what is Laplace transform of cos hyperbolic 280? We know that it is s by s square minus a square. Here in place of a you are having 2a. So 2a whole square will be 4a square. So that is how you got s by s square minus 4a square plus Laplace transform of 1 is 1 by s. So after taking LCM, we'll get the c s square plus s square minus 4a square into 1. So we'll get 2s square minus 4a square. And that 2 is common. And when you take that 2 common, no, that will get cancelled with this 2. And you're left with s square minus 2a square divided by s into s square minus 4a square. Next problem. Similarly, I have used the formula again, cos cube 80. Here I will get this cos cube term in cos 3x. Okay, so I have used the formula cos 3x. We know that cos 3x is equal to 4 cos cube x minus 3 cos x. So I have just rearranged the formula for cos cube x. Cos cube x is equal to 1 by 4 into cos 3x plus 3 cos x. See, when you take this minus 3 cos x this side, no, that will be cos 3x plus 3 cos x. And I need cos cube x, so I'll take this 4 this side. So that will be whole divided by 4. So this is how we will get. And Laplace transform of cos cube x is nothing but Laplace transform of this. So in place of x, you are having 80 here. So I have just replaced x by 80. So this is how you will get. Okay. Fine, and I have just multiplied that 1 by 4 to both the terms, and here already there is 3, so it's 3 by 4, and 1 here, so it's 1 by 4. And we know that cos 80 Laplace transform is s by s square plus a square. Okay, so for hyperbolic it will be minus, and for cos 80 it will be plus s by s square plus a square. So Laplace transform of this will be, okay, 1 by 4 are taken outside. Cos 380 is s by s square plus a square. In place of a, I am having 3a. So it is 3a whole square or 9a square plus 3. I have taken this 1 by 4 outside. Cos 80 is s by s square plus a square. With this 3, that becomes 3s by s square plus a square. So this is all about this problem. Next problem. So I have taken all type of problems when it is given like this, how to solve. So when it is sine 2t into sine 3t, you will be using this formula sine a sine b. Also, if you get cos a cos b, you can solve, and sine a cos b or cos a sine b, you will be using this formula. Okay, the sine a cos b, sine a sine b formula is cos of a minus b minus cos of a plus b divided by 2. So I have used that. In place of a, I'm having 2t. In place of b, I'm having 3t. Okay, so I can write this as half of this 2. I've taken that outside. Half of Laplace transform of cos a minus b. Cos a minus b is 2t minus 3t. That will be minus t. Cos of minus t is cos t. Okay, so cos t minus Cos A plus B is 2t plus 3t, that is cos 5t. And we know that cos AT formula. What is that cos AT? S by S square plus A square. In place of A, I am having 1 here, so it is 1 square. In place of A, I am having 5 here, so it is 5 square. So S by S square plus 1 minus S by S square plus 5 square, that is 25. See, when you take this LCM and all and you solve, you get this. Okay. So we'll move on to next problem. Cos AT plus B. If you get this type of problem, no? So you just expand. What is cos A plus B? Cos A cos B minus sin A sin B. In place of A, you are having AT, and in place of B, you are having B, small b. So when you use this formula, no, it will look like this. L of cos AT cos B minus L of sin AT sin B. Okay. So here in these two terms, no, cos B is a constant. We'll take that outside the Laplace. So it is cos B L of cos AT minus in these two terms, no, sin B is constant. So when you take this outside, sin B into L of sin AT. Okay. So we know Laplace transform of cos AT is S by S square plus A square, and Laplace transform of sin AT is A by S square plus A square. So I have just used the formula here. Okay. And remaining thing I have replaced as it is, sin B and this cos B. Okay. So we'll move on to next one. See here, L of A power t. We don't have any formula for this A power t, constant power t. But I can write this A power t in exponential form. Okay. How is that? I can write this as e power log A power t. Okay. See, I'll just show how I can write that as e power log A power t. Okay. Let f of t equal to A power t. I'll just consider this as f of t. And when you take log on both sides, you have log ft is equal to log A power t. Okay. Log f of t is equal to log A power t. And this log A power t, I can write this as t log A using the property of logarithm. Okay. So log m power n can be written as n log m. So I'm using this property. So I've written this as t log A. Or when you take this exponential on both sides, no, this will be e power log ft. E power log ft is nothing but ft. And here this will become e power t log A or e power log A power t. Okay. So this can be written as e power t log A. Now your function f of t is e power t log A. You can write A power t, or in place of A power t, you can write e power t log A or e power log A power t. Okay. So this is how we'll get this. And here e power at, for e power at you are having the formula. For e power at, the formula is 1 by s minus a. And in place of a, you are having log a. Now the constant here is, coefficient of t here is log a. So it is 1 by s minus log a. Okay. In place of a, you are having log a. So here 1 by s minus a becomes 1 by s minus log a. So this is all about a power t. Yeah. See, when you have two functions like this, t cube and e power minus 3t. Okay. See here, we know that L of t power n is n cube, n factorial by s power n plus 1. Okay. See here, here it is a whole number. So we have used this formula, n factorial by s power n plus 1. And also we have done this in standard formula, e power at t power n. Okay, that is equal to n factorial by s minus a power n plus 1. If Laplace transform of t power n is equal to n factorial by s power n plus 1. Then if there is an additional exponential here, e power at with this t power n, then you'll simply replace this s by s minus a. Here the coefficient of t is a. So you replace this s by s minus a. This is how the formula is. See here, I know what is L of t cube. It is 3 factorial by s power 4, s power n plus 1. So it is s power 4. 3 factorial is 6. So it is 6 by s plus s power 4. But you are having this additional e power minus 3t. Okay, in place of a, you are having minus 3. So here, you are replacing s by s minus a, no? That a is minus 3. Okay, so that becomes minus into minus plus 3. So this is how you will get s plus 3 whole power 4. So it is 6 by s plus 3 whole power 4. See here also, whenever there is this exponential term, no, first you can solve for this and then apply this exponential term by replacing s by s minus a term. Okay, so first we'll solve for sine square t. Okay, and when you want for this whole e power t with sine square t, no, yeah, you'll be replacing s by s minus a. A here is 1. So we'll be replacing s by s minus 1. So let's find what is sine square t. See, I am having the formula for sine square t, right? That is 1 minus cos 2t by 2. I've taken this half outside and I'm left with Laplace transform of 1 minus cos 2t. Okay, Laplace transform of 1 is 1 by s. Okay, and Laplace transform of cos 2t. Okay, what is Laplace transform of cos at? It is s by s square plus a square. In place of a, I'm having 2, so it is s by s square plus 2 square or 4. Okay, so it is 1 by s minus s by s square plus 4. And now, when you add this e power t here, okay, you'll be replacing s by s minus a. But here a is 1, so you are replacing this s by s minus 1. Wherever there is s, no, we'll be replacing that by s minus 1, like this. And this is the final answer. Yeah, we'll move on to next problem, that is L of sine hyperbolic at sine at. Laplace transform of sine hyperbolic at into sine at. See, I can write the sine hyperbolic at in terms of exponential. Okay, this is the exponential form of sine hyperbolic at. E power at minus e power minus at divided by 2 into sine at. And I have just split this using linearity property here like this. Okay, and now what I'll do is I'll just see what is Laplace transform of sine at. Okay, I know what is Laplace transform of sine at. It is a by s square plus a square. Now we'll find this separately. Okay, Laplace transform, when you add this e power 18, you'll just replace by s minus a. You will replace this s by s minus a. And here in place of a, you are having minus a. So you'll be replacing s by s plus a. Okay. So this is how it looks like after doing all these modifications. See your Laplace transform of e power 80 sine 80. What I have done, I have replaced s by s minus a here. And here there is minus a. So I have replaced s by s plus a. And I have used this 2 here in this equation. So I have Laplace transform of sine hyperbolic at into sine at is equal to half into, I have taken this half outside. Laplace transform of this is a by s minus a whole square plus a square minus this. Okay, I have taken all LCM. Okay, and when you solve this, no, you'll get like this. So I've just solved, you can just look it. Okay, final answer will be this 2a square s by s power 4 plus 4a power 4. And here I have just used the formula of a minus b whole square and a plus b whole square. I've just expanded it, and here also after expanding this and solving this one, we'll be left with only 4as. Okay, so this is the final answer. Yeah, now we'll move on to split functions. Like this. This is an example of split function. We'll be not having one function. We'll be having more than one function. When there is a function, when there is a single function, okay, when you're defining a single function for different intervals, okay, see here you have two different intervals. From 0 to 5 you have f of t defined as 2t, and from for t greater than 5 you have f of t defined to be 1. So this type of functions are called split functions. Okay, see here L of f of t, we know the definition of Laplace transform. L of f of t is equal to integral 0 to infinity e power minus st ft dt. Here see here you have 0 to 5 one interval, so 0 to 5 e power minus st. Here in this interval f of t is 2t. Okay, I'm just splitting this interval, guys, according to what they have given. So here integral for 0 to 5 f of t is defined as 2t. So for that I am making different integral. 0 to 5 I have written this f of t as 2t, and for t greater than 5, that is 5 to infinity, I have written this ft as 1. This one I have written that one here, and after that I have continued with the regular integral. See here I have used by parts. Okay, I have taken this for differentiation and this for integration. 2t into integration of this e power minus st by minus s between the limits 0 and 5 plus integral 0 to 5 integration of e power minus st by minus s, that here it's only I told it is plus. In formula you will be having minus integral of, because of this minus s, no, this one that has become plus, and the differentiation of this 2t is 2 into dt plus integral of this e power minus st is e power minus st by minus s between the limits 5 to infinity. And here when you apply the limits, upper limit is 10, 2 5s are 10, e power minus 5s divided by minus s, and the lower limit here is 0. When you apply 0 here to this t, that will be 0. And here when you integrate this actually this 2 by s is constant, I've taken that outside, and when you integrate this e power minus st, you will get like this, e power minus st by minus s. Derivative of this is minus s, and you have divided by that. In between the limit 0 to 5 plus upper limit here is 0, lower limit that is minus, with this minus sign that becomes plus, e power minus 5s divided by s. Okay, so when you solve this, you will get like this. Okay, fine. Yeah, we'll move on to next one. Okay, f of t is equal to sine t when t is between 0 and pi. Okay, and sine 2t for t greater than pi. Okay, so I have used the definition of Laplace transform. Okay, e power minus st ft dt. Okay, integral e power minus st ft dt 0 to infinity. So for 0 to pi, I have written this ft as sine t, and for pi to infinity, I have written this ft as sine 2t. And I know this formula, integral e power at sine bt dt is equal to, we have done this in PUC, okay, equal to e power at by a square plus b square into a sine bt minus b cos bt. So I'll be using this formula for both the integrals. Okay, in both the integrals, in place of a you are having minus s, and in place of b here you are having 1, and here you are having 2. Okay, accordingly I'll use this formula. So that looks like this: e power minus st minus s square plus, in place of b I told it is 1 for first integral, minus s sine t minus cos t 0 to pi plus e power minus st minus s whole square plus, place of b you are having 2 here, so it is 2 square minus s sine 2t minus 2 cos 2t between the limits pi to infinity. And when you apply the limits, it will be pi s e power minus pi s divided by s square plus 1. Okay, see here we'll just apply the upper limit first. So it is e power minus pi s minus s into sine pi is 0, so this is 0, minus cos pi is minus 1, so it is minus of minus 1, minus lower limit e power 0 is see here, in case of t I have written 0, so it's e power minus 0 or e power 0 into sine 0 is 0 minus cos 0 is 1 whole divided by s square plus 1 square, that is 1, plus, okay, upper limit first is infinity, e power minus infinity is 0, so I have written 0 here, minus lower limit e power minus pi s, e power minus pi s, sine 2 pi is 0 minus 2 cos 2 pi, cos 2 pi is 1, so it is minus 2 divided by, here it becomes s square plus 4. I have written that here, and after solving this we'll get, after removing all these zeros, we'll get like this. See here, minus into minus is plus, e power minus pi s, here e power 0 is 1, minus into minus is plus 1, e power minus pi s plus 1 by s square plus 1, plus minus into minus is plus 2 e power minus pi s, 2 e power minus pi s by s square plus 1. So this is how we'll get. We move on to next problem. F of t equal to e power t when t is between 0 and 5, and it is 3 when t is greater than 5. Laplace transform of f of t is equal to integral 0 to infinity e power minus st ft dt. So for 0 to 5 I have taken one interval, okay, and for 5 to infinity I have taken another list. For 0 to 5, f of t is e power t, so I have written that. And for 5 to infinity, that is greater than 5, I have f of t to be 3. And using all this, I have integrated. Okay. See here, I can write this using law of indices as 1 minus s into t. Okay. Here 1 t, I can write this e power t as e power 1 t. So, and here it is minus st. In both the exponential t is common. When you take that t common, you will get 1 minus s. Okay, and when you integrate that, you will be having e power 1 minus s into t divided by 1 minus s, and that is between the limits 0 to 5. And I've taken that 3, that constant outside, and I've integrated this, that is e power minus st by minus s. That is between the limits 5 to infinity. And now, when you apply the limits, okay, here when you apply the limits 1 minus s into 5 divided by 1 minus s minus the lower limit, e power 0 is 1, so it is 1 by 1 minus s. And here also, upper limit e power minus infinity is 0 and lower limit is 5. So it is e power minus 5s divided by minus s. So in next step, you can just remove this 0 and you can just write this minus into minus plus 3 e power minus 5s. Okay, fine. Yeah. If Laplace transform of f of t is equal to f of s, show that Laplace transform of cos hyperbolic at into ft is equal to half f of s minus a plus f of s plus a, and Laplace transform of sine hyperbolic at into f of t is equal to half f of s minus a minus f of s plus a. Yes guys, we have done this type of problem like this for e power 80. In place of cos hyperbolic t and sine hyperbolic t, we had e power 80 if you remember. Okay, L of e power 80 f of t we have done. We have written that as f of s minus a. Okay, if we have this in place of cos hyperbolic t, if we have e power 80 into f of t, we get f of s minus a. Okay, it is similar to that. In place of that, if you have cos hyperbolic 80 or sine hyperbolic 80, these are the formulas we should prove here. Okay, see, take one by one. The Laplace transform of cos hyperbolic 80 ft. Okay, see, I can write this in exponential form like this: e power 80 plus e power minus 80 divided by 2 into f of t. So Laplace transform of this. And I have split this using the property of linearity like this. And I have taken this half outside since it's a constant. And just now I told we have done this type of problem. L of e power 80 ft is f of s minus a. So we have used that standard formula, f of s minus a. And here in place of a, I'm having minus a. So it is f of s plus a. Okay, the same formula. In place of a, I'm having minus a. So it is f of s plus a. So this is how we'll get half of f of s minus a plus f of s plus a. So proved. Similarly, for Laplace transform of sine hyperbolic at into f of t, here also I have written this sine hyperbolic t in exponential form and I have taken that half outside. And again using the property of linearity, I can split these terms like this. And again Laplace transform of e power 80 f of t is f of s minus a minus Laplace transform of e power minus 80 ft is f of s plus a. In place of a, I am having minus a, so it is f of s plus a. So this is how you will get. Okay, move on to next one. I've just taken one example. See here, in place of f of t here, in place of f of t, we have taken e power 80. Okay, so we know that Laplace transform of e power 80 is 1 by s minus a. Okay, in place of ft, we are having e power t. So Laplace transform of e power 80 is 1 by s minus a. And here you are going to replace s by f of, yes, yeah, in first one there is actually two terms, half of f of s minus a minus half f of s plus a. That is for sine hyperbolic 80. You are having sine hyperbolic bt. So what you'll do is you'll write half of f of s minus b minus f of s plus b. Okay, see, and what is f of s here? F of s is 1 by s minus a. So using that formula, half of f of s minus b will be, see, in place of s I'm replacing s minus b. That's it. That is f of s minus b. This is f of s and this is f of s minus b. And this is f of s plus b. Okay, this is s minus b and this is s plus b. What is this? This is f of s. This is f of s minus b. This is f of s plus b. What is f of s minus b? In place of s, you have replaced s minus b. What is f of s plus b? In place of s, you have replaced s plus b. Okay, and after taking LCM and all, you'll get like this. See, when I take LCM, you'll get s plus b minus a, and with this minus s plus b plus a, and after all cancellation, you'll just be left with b divided by so and so. Okay, yeah. There are another two properties of Laplace transform. See, first one, in previous class we had gone through the first property, that is linearity property, and the second one was first shifting property. Okay, third property is change of scale property. Okay, change of scale property states that if L of f of t is equal to f of s, then L of f of at is equal to 1 by a f of s by a. Okay, if L of f of t is equal to f of s, then L of f of at is equal to 1 by a f of s by a. So let's prove that. By the definition of Laplace transform, we have Laplace transform of f of t is equal to integral 0 to infinity e power minus st ft dt, which is equal to f of s. Okay, and what is Laplace transform of f of at? See here, I've just used this. Sorry, in place of f of t, I'm having f of at. This one. Okay, so I've just used some substitution here. Put at is equal to u. See, I want f of s by a. Okay, see here, when you take this substitution and differentiate this, a dt will be equal to du or dt will be equal to du by a. See, as t varies from 0 to infinity, when t is 0, u is also 0. And when t is infinity, u is also infinity. So when t varies from 0 to infinity, you have u also varying from 0 to infinity. So I'll tell why I have used this substitution. See here, you can just see here. L of f of at is equal to 0 to infinity e power. See here, do not confuse with the thing. Function here is f of t. You are finding the Laplace transform of this function. And here you are finding the Laplace transform of this function. Okay, so you just can't replace t by at here. This is one function and this is another function. So in place of this function, you are replacing this function. That's it. Okay, do not confuse. And see why I've used this substitution. In place of, see here, place of t, I have u by a. Okay, t is u by a. So I have written minus s into u by a. And in place of at, I have u. So it is f of u. In place of dt, it is du by a. F of u du by a. And here 1 by a is constant. I've taken that outside. And e power minus su by a into fu du. You're left with. And this is nothing but f of s by a. See here, this is the same as definition of Laplace transform. Like in place of t or having u, that's it. Okay, but here you can see you are not just having minus su fu du. You are having minus s by a into u fu du. So in place of s, you are having s by a. So that is how you will get f of s by a. See, just if you had e power minus su fu du, you would have written f of s. But in place of s, you are having s by a. So it is f of s by a. And this 1 by a here I have written. Okay. So this is how you will get 1 by a into f of s by a for Laplace transform of f of a t. Okay. And we'll move on to this last property. There are total 4 properties. Okay. First one is linearity property, second first shifting, and third one is change of scale property, and fourth one is second shifting. Second shifting property is also known as translation property. So what is this stating? If L of f of t is equal to f of s and g of t is equal to f of t minus a for t greater than a and 0 for t less than a, then prove that L of g of t is equal to e power minus as into f of s. So we'll prove this. Okay. According to this Laplace transform, L of gt can be written like this. Like in place of the function f of t, I'm having g of t. So in place of f of t, I have written g of t in the definition. What is that? Integral 0 to infinity e power minus st gt dt. And see, for gt, it's actually a split function. Okay. For t greater than a, you are having one function, and for t less than a, you are having another function. T less than a means from 0 to a. Okay. From 0 to a, you have 0. G of t. G of t is 0. So I've written 0 here. And for t greater than a means from a to infinity, it is f of t minus a. So I have written that function here in place of g of t in this interval. And this vanishes because there is a 0 here. And here 0 to a, a to infinity e power minus st f of t minus a dt. You are left with only this integral. Okay. See here also, for this, in previous problem, in previous property, we had substituted for this f of at. See this at we had substituted, and here for t minus a you are using the substitution. So for t minus a, if you take u, that dt will be equal to du, and as t varies from a to infinity. See here, this is for a to infinity. That is for t, it is a to infinity. So when t is a, no, you will get u as 0. Okay. So when t is a, u is 0. And when t is infinity, u will also be infinity. Infinity minus a is infinity. So when t varies from a to infinity, u varies from 0 to infinity. Okay. So I have used all this, that is t minus a equal to u and dt equal to du, and this variation for u. Okay, here in this previous integral. Okay, so this becomes 0 to infinity. Okay, and here e power minus st, t is a plus u. So here it is a plus u, f of u, because we have taken this as t minus a as u, no? So it is f of u, and dt is just du. Okay. See, you can take this e power minus. See, this can be written using law of indices as e power minus su into e power minus sa. I have just split this term and I have used the law of indices. See, I can write this as minus su minus sa. And again, using law of indices, it is minus su e power minus su into e power minus sa. E power minus sa has nothing to do with this integral, because that you are integrating with respect to u. So it's a constant. I've taken that outside, and this u term I have written it here inside the integral. So it is 0 to infinity e power minus su fu du. Okay. So here this part, when you look at this part, no, this is nothing but f of s. Integral 0 to infinity e power minus su fu du is f of s. So L of gt is equal to e power minus sa, and this integral as f of x. Okay, so this is all about the fourth property. Thank you. We'll meet in next class, guys. Thank you.